Hi, eighth graders. Happy Tuesday. Hopefully around you all the snow has melted. It's working on it here in Schaumburg, and hopefully things are going well. We are getting closer and closer to spring break, so keep pushing on through this week. All right. Yesterday we went back to Unit 1 when we were talking about rational and irrational numbers and approximating square roots. Today we're going to do a quick review from Unit 3, and specifically going to focus on what is a function and what is a non-function as we go through today. Just a reminder that at 1 o'clock we are going to play Gimmick live. So that'll be with our whole team. We did it with my just one of my classes last week, and it was such a blast. So tune in if you're free at 1 o'clock. Might as well play. There'll be fun information, teacher facts, trivia. It's not all math related. So please tune in. It'll be a good time. All right, your goal for today is that you can identify functions and non-functions. If you have your spiral notebook, this would be a good page to go find and to go turn to. So this is like when we talk about the definition of a function, characteristics, and examples and non-examples. These are going to be the most helpful for you, especially when thinking about your assignment for Tuesday. All right, so if you take a second, go find this in your spiral. Otherwise, maybe you take a quick picture of it with your phone. That might be a good idea. All right, so let's get into it. So a function is a relation in which every input x has exactly one output y. So every single x is only matched with one y. That is fancy wording for saying that all of your x's are different. This right here, this is going to be the most important thing that you're going to be looking at and driving you through this lesson is, are all of my x's different? If they are, then it is a function. If they're not, then it's not a function. So keep this, right, this like item here in red, keep that in your head as we go through today. Please remember that there are 4 ways to view a function. There's 4 different representations, and you'll have to be versatile in all 4. The first one is ordered pairs. Okay, that's when we just list out all of these coordinate pairs to see if it's a function or non-function. Now, the reason that this is a true example is because if you look at your x values, you've got 1, you've got 3, and you've got 5. All of those are different, therefore it is a function. But if you look in this non-example category, you've got 1, 3, and then you've got 1 again. Because you have the repeats of the ones, that makes it a non-function. Okay, that would make it not work. For example 2, when we're looking at tables here, again, you only have to look at your x categories. Okay, so when you're looking at this table, I'm just looking here at my x's. So I've got -4, I've got -2, 0, 3, 6, 7, 8. Even when I read those down the list, they're all different, which makes it an example. But over here for your non-example, I'm like, all right, I've got 1, 2, 1. Notice that you have 2 of the same x's. That makes it a non-function. As soon as you see the repeat, you can just kind of keep going because you've already figured it out. Looking at another example, another 2 examples, if you're looking at your x category here, you've got 1, 2, 3, 4, 5. Those are all different, so that is a function. This guy here, this table though, hopefully you see the repeats in the inputs. So I see I've got 2, 4, 3, and 2. As soon as I see that I've got these 2 2's, not a function. Can't have the repeats. All right, moving on. So we looked at ordered pairs. We looked at tables. Now we're going to representation number 3. Hopefully you remember mapping diagrams. Those are like those fancy ovals with the arrows going from inputs to outputs. Your key here when you're looking at mapping diagrams is that you want to make sure that every input only has one arrow coming out of it. So notice you've got 10, 20, 30, 40. All of those have one arrow. That makes it an example because it is a function. Over here though, you see how you've got the 2 arrows coming from 0? You cannot have that. Okay, that makes it a non-function. This one input of 0 has 2 outputs. That does not work. Okay, so with mapping diagrams, your clue, make sure that every single x or input has exactly one arrow coming from it. All right, moving on to the last one. Now, graphs are a little bit special because we have this special test that we use to determine if it's a function or non-function. Do you remember the vertical line test? Okay, if you remember sitting in class with me, I'd always tell you to draw the line going down your graph. We're going to do the same thing here today. So if I was looking at this graph and I draw a vertical line going down, notice that it only hits your graph here one time. It hits one time. That makes it a function. However, if you were looking at this example over here, and let's use a pen because it's not as thick as a highlighter, if I drop this line going down and we're going to pretend that it's straight, notice that it hits your graph here and it hits your graph here. Because it hits 2 times, it makes it a non-example. It is not a function. Let's look at that again. I've got 2 new graphs. Knowing that I'm determining if it's a function or non-function, I know that I have to use the vertical line test. So taking one of your pens, or even you can like hold your pencil up to the screen for you to see, if I dropped a vertical line going down here, notice I've got a hit number right here, and I've got a hit right here. Because I have those 2, it is not a function. If I drop a line here though, notice that it only hits my graph 1 time. That means that it passes, it is a function. So just quickly to wrap up, when we're looking at functions and non-functions, it's the most important thing for all of your x's to be different. There's 4 different ways to view them. We've got ordered pairs, we've got tables, we've got mapping diagrams, and we've got graphs. And remember for your graphs that you just have to draw a vertical line going down. If it hits 2 times, then it fails. One more thing to look at. Let's take a look at just this coordinate plane. Okay, let's say that it just used coordinate points like this. They weren't connected or anything. So just focus on these 3 black dots. If I just gave you a graph with these 3 black dots, it would be a function because if you drew a line down any of them, they wouldn't hit twice. But let's say that I added one right here. If you drew a line going down there, notice how it hits the 2 of them here. That would make it not a function. So I believe you see 1 or 2 of those in the quizzes game, so just be aware. Okay, so for your Tuesday assignment, you've got 2 things. Number 1, you've got the function, non-function quizzes. The link for that with the code is in the e-learning folder. It's also linked in the Schoology update. So you can just go to the post that I posted this morning. It's linked in there. Problem solving number 4 is due by 11:59 Thursday. I had a lot of kids last week that asked me to submit it like Friday morning, Friday afternoon. It is due by 11:59 Thursday night because I go over it via video the next day. So make sure that you get it done. If you have questions, message me. I hope you guys have a wonderful day. Miss you as always. If you need me, let me know. Bye.